Now we are going to graph an equation that has a fraction as its slope. So y equals 5/3 x plus 2. That's going to be the example that we're using. And again, we are going to draw a table for the x and y coordinates. Now, if you can remember when we were doing equations that had a integer slope, we used the default of -1, 0, 1. The reason we did that was because we were trying to find numbers that would be the easiest to use and would end up giving us an integer value for y. We could use -1, 0, 1 for a fractional slope. However, it's not going to give us an integer y value and make it, it's still possible to graph, but it's a little trickier. So remember in the previous problem we had the equation y equals -4x plus 3. And this was an integer slope, but the denominator in this integer slope is 1. And so when we were picking the numbers to plug in for the x, we were using the denominator of the slope and its opposite. So 1 and -1, and then 0. We're going to do a similar thing here to where we are using the denominator of the slope and its opposite. So in this case, the denominator here is 3. I'm going to use -3, 0, 3. And we're going to plug this in to the equation. So y equals 5/3 times -3 plus 2. So I took the x out, replaced it with -3. The 3's will cancel out because it's really 5/3 times -3 over 1. That cancels out, but I still have a negative and the 5. So I have -5 now, -5 plus 2. -5 plus 2 is -3. So in this equation, when x equals -3, y equals -3. Then we do the same thing, this time taking x out and replacing it with 0 plus 2. Anything times 0 is 0. So 0 plus 2 is 2. So in this equation, when x equals 0, y equals 2. And then last but not least of all, y equals 5/3. Take the x out, replace it with this x value that we have chosen, and that would be 3 plus 2. Cancels out, the 3's cancel out. There's no negative there, so I'm going to go ahead and add that up, or bring down my 5, because that's what's left there. 5 plus 2, and that equals 7. So in this equation, when x equals 3, y equals 7. Then we go ahead and graph it. I have -3, -3, -3, -3, 0, 2, and 3, 7. 3, 7. And I graph the line. So I'm going to graph here. Draw my line. I can double check my answer here by seeing, okay, this is a positive slope. It is reflected on the graph as a positive slope. The y-intercept is +2. There it is. And the slope is 5 over 3. So starting from this point, I rise 5. 1, 2, 3, 4, 5. Run 3. 1, 2, 3. And there we go. I'm going to do another example. This time using the equation of y equals negative 1/5 x minus 8. And I'm going to draw my x and y table. And this time, the denominator is 5. So that is what I'm going to use for my x. I'm going to use 5 and its opposite. So negative 5. Negative 5, 0, 5. Negative 5, 0, 5. And then I will solve. Y equals negative 1/5 times negative 5 minus 8. The 5's cancel out. And also remembering the rule of a negative times a negative is a positive. The negatives here cancel out. So I'm left with 1 there, minus 8. 1 minus 8 is negative 7. So in this equation, when x equals negative 5, y equals negative 7. I'm going to do the same thing. Y equals negative 1/5 times 0 minus 8. Negative 5 times 0, or excuse me, negative 1/5 times 0 ends up being 0. So 0 minus 8 equals negative 8. In this equation, when x equals 0, y equals negative 8. And lastly, y equals negative 1/5 times positive 5 minus 8. The 5's cancel out, but there's no negative on this 5, but there is a negative left over here. So now I have negative 1. Negative 1 minus 8 equals negative 9. So in this equation, when x equals 5, y equals negative 9. Going to now plot my points. So I have negative 5, negative 7, negative 5, negative 7, 0, negative 8, and 5, negative 9. Right there. Draw my line. And I'm going to check my answer here. I have a negative slope, and that is reflected in the line on my graph. The y-intercept is negative 8, and my slope is negative 1/5. So from this point, I go down 1 over 5. Down 1 over 5. And that is graphed correctly. One last thing I want to point out is that as we saw with when there was an integer slope and now with the fractional slope, you get to the point where you do not need to actually work out when x equals 0, because every time 0 cancels out the slope and you're left with the y-intercept. Every time. So it cancels out the slope and it leaves you with the y-intercept right there. All right. Otherwise, you do need to show the work for the other 2 points.